In this illustration, we'll be calculating the force by hinges on a door. We are given that a door of 100 kg mass, which is supported by two hinges A and B on a wall, is of size 4 meter by 3 meter as shown. And it is saying if the force by hinges on door are equal, we are required to find these force exerted by hinges. Now, in this situation, we can first redraw the figure and the forces acting on the door for analysis and better clarity. This is the door. At its center of mass, its weight mg will be acting. And for these two hinges A and B, here we can see to balance the weight, a vertical force will be applied by the hinges on the door. And these we can write as FB and FE, as these two must be equal. And if the upper hinge is open, the door will rotate about the lower hinge in clockwise direction. That means the upper hinge is providing a horizontal force FH toward left. And similarly, to balance it, lower hinge will provide a horizontal force FH toward right. Now, in this situation, we can write as door is in equilibrium. Here we use, in this situation, we can write one thing is twice of FV is equals to mg, which will give us the value of vertical force applied by the two hinges, that is mg by 2. And the mass is 100 kg, g we can take as 10. So this 100 multiplied by 10 by 2. So the value of vertical force by hinges is 500 Newton. And if we wish to calculate the horizontal force by the hinges, we can make use of rotational equilibrium of the door. We can write as door is in rotational equilibrium. We can use net torque on door about any point is 0. And this implies if we calculate the torque about the center of mass, then the torque of mg will be 0. And that of FV, we can write the torque is equals to 2FV multiplied by, as this width is 3 meter. Then the distance of line of action of FV from the center is 1.5 meters. So the torque will be 2FV multiplied by 1.5. And this is in clockwise sense, and the torque due to FH will be in anti-clockwise sense, so we can subtract it. The torque due to FH is this distance we are given as 4 meter, and the distance of hinges from the edge of the door, top edge and bottom edge, is given as 1 meter. So this distance of FH from C is also 1 meter. Same is for this FH. So this can be written as 2FH multiplied by 1, and this should be equals to 0. So on solving, this gives us the value of FH is equals to 3FV by 2. And if we substitute FV as 500 Newton, this will be 3 by 2 multiplied by 500, that is 750 Newton. So we can now calculate the force exerted on door by each hinge can be given as net normal reaction, or the net reaction applied by the hinge on the door will be root of FH square plus FV square, as these are acting normal to each other. So this root of 500 square plus 750 square. On simplifying, this will give us 250 root 13 Newton. That is the result of this problem.